Today we're going to go over Topic 1, Lesson 2, Measuring Matter. This goes with your textbook pages 14 through 20. If you haven't opened your textbook already, please do so to page 14. Expressing weight, mass, and volume. So those are three vocab words we're going to talk about and their differences. So the first one is mass, and mass is the amount of matter in an object. Okay, so we talk a lot about mass in science, and then we're also going to talk about something called volume. And volume is the amount of space that a matter occupies, how much space it takes up. Okay. The last one we're going to talk about is weight. Weight is the measure of force of gravity on an object. And so what's the difference between mass and weight, because a lot of people get them confused, is weight is the force of gravity on you. On Earth we have gravity, that's what keeps us on Earth. And so the amount of gravity pushing on our bodies is what affects our weight. And the difference between that, mass is not affected by gravity. Okay, so if we go to the next slide real quick, it says weight changes based on the force of gravity. So you could weigh something different here in Illinois than somewhere else on Earth, because everywhere there's different forces of gravity depending on your place you're at, whether you're in California or in Europe. There's different forces. It varies a little bit. It also varies a lot on different planets. You guys know that. You've seen people, on the moon where they're floating or kind of moonwalking, bouncing, because the gravity is different. And so weight changes based on that. Well, the thing about mass does not change based on the gravity. Whatever mass the object has on Earth, it'll have that same mass elsewhere. Okay? Now, on Earth, and we're going to look at this diagram right here. You also have it in your book. On Earth, the bananas on the scale weigh 2 pounds. So we're talking about weight here. What do you think it would weigh on Jupiter? Now draw the missing hand on the face of the second scale to indicate your estimate. So remember, this is an estimate. Now, I will tell you that the force of gravity is greater on Jupiter. That gives you any indication of what your estimate should be. Okay, so, once again, this was just an estimate, so it's what you thought. Now, on Jupiter, these bananas will weigh somewhere between 4 and 5 pounds, okay, because there's more gravity being forced upon them that makes them weigh more in Jupiter. All right, so we already talked about the first point and the second point. But what do we use in science to measure mass? So this is what we use in the classroom. This is called a triple beam balance. And I'm going to demonstrate how we use this to measure different objects in just a moment. One of the system that scientists use is called the International System of Units. Scientists use this system because they want things to be the same, no matter where the report, where the experiment, where the data is being read. So what that means is if a scientist does an experiment here on Earth, or in the United States, and they repeat it over in Europe, then they will be using the same units. Now, if you're not aware, the United States uses what's called a customary system. That's our inches, feet, mile, pounds, so forth. We are one of the only few countries that actually use the customary unit. Most everywhere else uses what's called the metric system, which is the meter, grams, and so forth. So scientists use this system so that they make sure all the data is in one format so that they don't have to convert from feet to meters or grams to pounds and so forth. Now this SI is the abbreviation for this system, and the SI unit for mass is kilogram. And this diagram right here shows you all the SI units for if you're measuring length. The base unit would be meter. That's why we have, millimeter, centimeter, meter, kilometer is how we measure it. The mass right here, kilogram. We have grams. We have centigram, milligram. We do measure mass in those. So how do we use a triple beam balance to measure mass? Watch the video to find out. So I'm going to show you how to measure using a triple beam balance. It's a triple beam balance. These are called sliders. They slide up and down. The first one has the smallest, it only goes to 10 grams. The middle one is the largest, it goes to 500 grams. And then the back one goes to 100. So with that being said, the biggest item we can measure on this graduated cylinder can only be 610 grams. So I'm going to show you how to use this. So I'm going to measure a few common items. The first one I'm going to use is a bottle of glue. So I'm just going to set that on there. I can set it like this, set it this. Either way, as long as it's on the pan. And then I'm going to move the sliders. Okay, I'm going to start with the largest one, and I'll move it over one at a time until it drops down. When it drops down, you move it back one. Your goal is to get this line right here even with this line here. Okay, so I moved that one back. Then I go to my back slider and I'm going to move the same way, one at a time, until it stops. And I think this one. Okay, one at a time until it drops. There we go. So I would move it back one until it's up. And then this one, you just move, and I usually use the tip of my fingernail to just move it. And then soon you'll see that this starts to go up and down. And so we want it to be perfectly even. Okay? And there we go. So we have it perfectly even. Now, what we do is we read what's on the three sliders and then add them together. So we have 100, then we have 10, so we have 110, and then this is at 6. So we have 106 grams that this glue weighs. Okay, I'll take that off, and then we reset our sliders so they're all at 0. And then I'm going to do a calculator. So I'll put that on there. And once again, we move it one at a time until it falls down. There it is. Once it falls down, you move it back. There we go. And then I go to the back slider. And then the front slider. It's going to be really close to what the glue weighed. And there you go. So I have 3 sliders. Now in your guided notes, I want you to add up what this equals. There's the 2 back sliders, and there's the front one. So on your guided notes, you're going to tell me how much the calculator weighs. All right, so we're going to talk about volume. Volume is the amount of space that matter takes up. So if you were holding a box in front of you or a basketball, the amount of volume is the amount of space that's taking up. Okay, the SI, or the International System of Units for volume, are meters. Now, one thing that we're going to talk about is we can measure solids and we can measure the volume of liquids. But one thing that you might think might be a little bit difficult to measure the volume of would be gases. So think of a gas as like helium. So a balloon is filled with helium because gas does not have a definite volume because it doesn't have a shape. You know, if you pop that balloon, the helium is everywhere. So it doesn't have a definite shape. So what we do is we measure the volume of the container it's in, or the balloon that it's in. So what it says here is gas does not have a definite volume because their particles fill their container. We measure the volume by measuring the units of its container. So we measure the volume, and the amount of helium is by measuring the amount of space that the balloon takes up. Now, so how do we measure volume? There are two different ways, and watch the video now to find out how.
So, how we find volume? We find volume for irregular and regular solids. What a regular solid would be, something that has three sides, because the formula for volume is length times width times height. So what I would do to find the volume of a regular solid, I would measure my length is 22 centimeters times the height, which is 9 centimeters, times the width, which is 12 centimeters, equals, and I'm going to put this in my calculator, and I would do 22 times 9 times 12, and I get 2,376 centimeters cubed. It would be cubed because this is a cubed shape. Now, what if I want to find the volume of this marble? Obviously, I can't measure the three sides of this marble. So what you do for regular solids is you take a graduated cylinder, and I'm going to fill it up with water from this beaker. I'm going to go to 50 milliliters. And then what you do is you drop the marble or the object in, and then you read. So it was at 50, now it's at 53. So 53 minus 50 equals 3. So the volume of this marble is 3 milliliters. Okay? And that's how you find the volume of an irregular and a regular solid. Let's do one more irregular. I'll show you something. So if I fill it up with water again, I'm actually going to put it to 60. That's good. And I'm going to find the volume of this clothespin. So I would drop it in, and it actually sinks. If it wasn't to sink, then I would just use the tip of a pencil, actually works the best, and would push it down so that it's below the water surface. And this went up to 68. So I started at 60, so 68 minus 60 equals 8. So the volume is 8 milliliters. Now, if there is something that can't fit, we do have different sizes of graduated cylinders, but if there is an object that doesn't fit in the graduated cylinder, we would use what is called water displacement. And we're going to talk about that on another day, but there are ways to figure out the volume of even the largest items. All right. Have a good day.
So now I'd like you to pause the video and try to complete the math toolbox on page 17. So pause now to complete. Okay, now that you've tried the math toolbox, I'm going to go over it with you. I know that this was kind of difficult, but so we have two different ways of calculating volume, like we said. One, objects of a regular shape. That's what I refer to as a regular solid, but they call it regular shape or regular solid. That means you can find the length times width times height. So right here they have a suitcase, so they say the volume of the object of a regular shape can be calculated by measuring the object's dimensions. For example, the volume of a box-like piece of carry-on luggage that is 20 centimeters deep, 30 centimeters wide, and 45 centimeters long can be calculated by using length times width times height, So the problem you should have completed was 20 centimeters times 30 centimeters times 45 centimeters. And that should have equaled 27,000 centimeters cubed. Now it's very important that you put a label. Labels are important when using in science, because we don't know if it was 27,000 grams, 27,000 millimeters cubed, so you want to make sure that you do put that label. So the label is 27,000 centimeters cubed, and how you write centimeters cubed is the centimeters, lowercase cm, and then a little tiny 3 in the right corner, kind of like an exponent. Now for number 3, it's talking about objects of an irregular shape. So this would be objects of an irregular solid, ones that don't have the standard length times width times height that we can measure. So that's when we found volume by submerging an object in water, which is called the displacement method. So the question asks, design a solution. Suppose the irregular shaped object is a massive whale shark that is about to be moved into a cubed shape aquarium tank. How might you combine the length, width times height formula with the displacement method to determine the shark's volume? And then explain. So what you would do is you have a cubed shape aquarium, and so you would mark on the aquarium where the water height comes to before they would put the whale shark into the water. And so then they would mark the part where the water was before. They would put the whale shark into the tank, and then they would mark the water where it comes up to after the whale has been put into the tank, or the whale shark has been put into the tank. And what they would do is they would measure from the place where it was before to the place where it is now, and that would be the height in the formula. And then since it's a cube-shaped aquarium, they would do the length times the width. And that's how, and then they would use the formula and multiply the 3 together. And that's how they can use the displacement method to determine the shark's volume. Now we're going to talk about density. So density is the measure of mass of a material in a given volume. So there's a formula for density, and it's the mass divided by volume. Now, we're going to watch a density demo, which I think is super cool, and then we'll talk about it more when it's over. So here is the video. All right, so let's talk about that demo for a little bit. So it was a pretty cool demo. I really, really like that one. We don't have the supplies at school to do it ourselves, but it's a really cool video. So now what this is showing is basically what density is density is how stuff is packed into a particular volume. So in this video, they had all these different liquids, and they were all the same amount. They had, I believe it was 1/4 a cup of each liquid. And you can see they look like they're the same. So the differences here is their densities. So the lighter liquids, you know, the water, vegetable oil, are less dense than the heavier liquids, the honey, the corn syrup. So they float on top of the heavier liquid. So the different densities, they have different densities because they have different masses. Because we just talked about that the formula for density was mass divided by volume. Okay, so they're all the same volume, but they all have different masses. That's why they appear to be floating or sinking, depending on which one it is. So the more mass it has, it'll sink. So the maple syrup has more mass than the milk because it appears that the milk is floating on top of the maple syrup. And then the water is less dense, has a lower density than the dish soap. So now let's talk about the objects in here. So we have the ping pong, a cherry tomato, popcorn kernel. So the ping pong is the less dense of them all because it's floating on top of everything. But you're probably wondering, like, how did the cherry tomato get down here and then stop halfway? Well, it stopped when its density, when the liquid below it had a higher density than itself. Okay, so that's where it stops and it appears to be floating on top of the milk. Same with the popcorn kernel. Now the bolt has a higher density than all of these liquids. That's why it fell straight to the bottom. Now over here, it shows you the density of all of these items. And so you can see the honey has the highest density. And this says baby oil. It's lamp oil in the video, but it's the closest thing, has the lowest density. So there's similar liquids there. All right, there's not many things that affect density, but one thing is temperature. It does affect density. The temperature increases, the less dense an object becomes. So the temperature decreases. As the temperature decreases, the more dense it becomes. So you can see we have a chart, and this is in your textbook, of density of water versus temperature. So we have 0 degrees here, and it shows the density. Now the density of water, if you were just to Google the density of water, it's going to come up that the density is 1. That is a common fact. But, like I said, temperature affects density. So water at different temperatures is going to vary the density a little bit. So you can see that it decreases a little bit when it gets to a higher temperature. And then when it goes to a lower temperature. So right here, we have density. This is 0 degrees Celsius. But the density is different. You can see that on the chart with the line graph that goes straight down. Because we have it here and it's here. So what would make that, what would make that happen? So, temperature affects it as well, but do you notice a difference between these two things? If not, think of it, water is a liquid, ice is a solid. So there is a little difference when the water changes from the liquid form to the solid form. And that's what affects this density here. All right, calculating density. So here's our volume. Density equals mass divided by volume. And now we're going to do some examples. So turn to this page in your book, and we're going to work on these density examples. All right, so we're going to use density to figure out which one of these items is what type of mineral, rock, etc. So what scientists do is if they find all these, and they all look very similar, and we can see that one of them is gold, so they all look very similar. So they want to find out which one is which. And so they've found these items before, and they have their density calculated. So they want to see which one is actually gold. So they're going to use density to find that out. So we're just going to take the mass divided by volume. So let's figure out the mass of all of these, and then we can figure out which one is actually the real gold. So we're going to take 284 divided by 14.7. And if you put that in your calculator, I don't expect you to do that in your head, you're going to get 19.319 and so on. Well, we're just going to go to the round to the nearest tenth. So we can find that this one is 19.3. And now I want you to try the other three, on your own, and we'll compare answers. So pause the video now, calculate the three densities of muscovite, biotite, and pyrite, and then we'll do them together. Alright, so the density for muscovite, if you would have done 67.2 divided by 24, is 2.8 grams per centimeter. Sorry, I forgot to put my labels here. And then if you did 60 divided by 20 for biotite, you got 3.0 grams per centimeter squared. They never make these boxes big enough for me. And then for pyrite, you do 120 divided by 24, and you get 5.0 grams per centimeter cubed. So you can use these numbers down here to figure out which one has been reached. So we know that 19.3, this one is gold. 2.8, this one is muscovite. Then we know this one is biotite. And this one is pyrite. And so they use this to figure out which one is the real gold, because actually pyrite's nickname is called fool's gold. And so, and you can see it looks, pretty gold-like. So they call this pyrite fool's gold. But you can definitely see there's a huge density difference between the real gold and the actual pyrite. All right. Thank you very much.